Okay, today we are in 6.1 and we're looking at systems of equations. Now there are actually several ways to solve a system of equations, but let's just start right here with what a system of equation is. A system of equation is at least a pair of equations, say, and x plus 2y is equals to 1 is equals to 2, where the x value and the y value are the same. Generally speaking, when you have an equation with one unknown, you only need one equation to solve. But when you have two unknowns, like in this example right here, you need actually more information. So what you need is a second set of information, a second equation. So we call this equation 1, we call that equation 2. And generally that's enough to get us to the answer to two equations. The key thing to understand right here in that this equation, this system of equations right here, both x and y are the same number. So how do we solve a system of equations? There are two methods. The first method is called, well, there are more than two, but we'll cover two here. The first is called the method of elimination. So in the method of elimination, what we do is we try to get rid of one of the variables, and that'll just allow us to figure out what the other variable is. And so what we do is we first pick a variable to eliminate or get rid of. Choose a variable. And in this case right here, we'll choose y. Technically, it does not matter which one you choose. You can choose whichever one you want. In this case right here, we'll choose the y variable. And then what we do is we inspect the two y variables that we have. I look right here at my first y variable, and I can see that the coefficient is 1. Then I look at my second y variable right here, and I can see that the coefficient is 2. What I need is to get those two y variables to cancel out. And so what that means is that I need them to have the same coefficient but opposite sign. And so what I do is I take the number in front of the first y variable and I multiply the first equation by that number. So I multiply this equation by 2. Then I take the other number in front of the other y variable and I multiply by that variable. In this case right here, that's a 1. Now I have to be careful right here. I want the signs to be opposite. So when I multiply right here, both of them will be 2, correct? This will end up becoming a 2, and this is becoming a 2. And 2 plus 2 is 4. I need them to eliminate, so I'm going to make this second one right here negative. And I'm going to multiply the first equation by 2. And I'm going to multiply the second equation by negative 1. And in so doing, I will get a system that can simplify nicely. So the first equation will become 4x plus 2y equals 2. Note that every element got multiplied by 2. And in the second equation, I get negative x minus 2y is equals to negative 2. With that, I then add each column one at a time. So the first column right here, when I add those two, 4 minus 1x, 4x minus 1, I will get 3x. The second equation, the y's will be eliminated, hence they call the method of elimination, because 2y minus 2y is 0. And then the last right here, 2 minus 2 is 0. That takes us to a very simple equation that I can solve. I have that 3x is equals to 0, and so that tells me then that x equals 3. Now that I know that x equals 3, and I remember that the x value is the same in each equation, x equals 0. Oops. X equals 0. Now I know x equals 0. I can use that to solve my equation. So I choose one of the two equations. Let's choose the second equation. So we say using the second equation, which is x plus 2y is equals to 2. And then I plug in x equals 0. 0 plus 2y equals 2. I simply have that 2y is 2, so y is equals to 1. If I go to my two equations and I try out those two answers, 0 and 1, I'll see that both equations work out perfectly. And so we say the solution is the ordered pair 0, 1. That is the only pair of numbers, 0, 1, that will satisfy both equations at the same time. I can look as much as I can, but I will not be able to find another pair of numbers that take me to that exact answer. Let's try another example. Let's say I have x plus 3y is equals to 11, and then I have 5x minus 2y is equals to negative 1. And that's my pair of equations. This is equation 1, that's equation 2. I need to eliminate. Let's go ahead and eliminate y one more time. Again, you don't have to eliminate y. You can eliminate any variable you so choose. And so I look at my coefficients. Well, my coefficient here is 3, and my coefficient right here is 2. And so this equation up here, I'll multiply this one by 2, and I'll multiply this one by 3. And so you're thinking, well, why didn't I make this up here negative 2? Well, if I make it negative 2, then both of them will be negative. Remember, I need only one of them being negative. And since I need only one of them being negative, and since I need only one of them being negative, and since this one is already negative, I can just multiply this one by 2 and multiply this one by 3. And so what I get are 2x plus 6y is equals to 22, and I get 15x minus 6y is equals to negative 3. Again, if I look very closely at the y's when I'm answering, the y's will cancel out. So I get that 17x is equals to 19. Again, that's a nice, neat, simple equation. So I just divide by 17 and divide by 17. So x equals 19 over 17. And if you're like me and you don't really like working with fractions, you can just go back to the same equation and then just eliminate the other variable to find the other answer. So you have 3y equals 11. You have 5x minus 2y is equals to negative 1. But now I want to eliminate the x's. So the first one I'll multiply by 5. And the second one I'll multiply by negative 1, because again the signs are the same. So you have to use one of them for negative. And that will give us, multiplying by 5, 5x plus 15y equals 55. And then negative 5x plus 2y is equals to 1. And add. This time the x's eliminate, and so I get 17y is equals to 56. And then I divide by 17. And so I get that y is equals to 56 over 17. And so my solution set is going to be 19 over 17, comma, 56 over 17. Not that bad, right? So that's your solution set. And note again, we only get one solution. This right here, although I get an x and a y, this is considered to be one solution. Because it's the pair together, that's the solution to the equation. If I was to make y a different number, I wouldn't be able to find an x that balances out both equations at the same time. So there's only one possibility, and so we say we have exactly one solution. Just like in the previous example, we had one solution only in there as well. So the second method is the method of substitution. So in the method of let's start with the same question we started from number 1. So we can see that they get the same answer. That's just bad. And so I have my 2x plus y equals 1, and my x plus 2y is equals to 2. And in this case right here, the first step right here is to choose an equation, any equation, and then solve for a variable. So let's say we want to get rid of y right here. So I'm going to choose that equation, and then I'm going to solve for y. In this case, that's pretty easy, just minus 2x on both sides. And so I get that y is equal to 1 minus 2x. Now that I have that equation for y, I take that equation for y and I plug it into the other equation. You cannot plug it back into the same equation. You have to plug it into the other equation. If not, you'll be solving the same equation twice. And so what that means right here is that my second equation becomes x plus 2, but instead of writing y, I write 1 minus 2x. Y is equal to 1 minus 2x. And of course, that is equals to 2. I distribute and I solve. If I look very carefully, you'll notice I only have x's in my equation. I have substituted for y, and so now the y is gone. Gone? Oh man. And so then I can solve my equation. So x plus 2 minus 4x equals 2. And so subtract. Negative 3x plus 2 equals 2 minus 2. Negative 3x equals 0. And so I get x equals 0. Just like we did a while ago. Now that we know that x equals 0, you can substitute x equals 0 into any of the above equations. They are all viable candidates. The easiest equation tends to be the y equation, and so y is equal to 1 minus 2x, y equals 1 minus 2 times 0, y equals 1. And so my solution is 0, 1. Just like we did before, we got exactly one answer, which is what we expected to get. Yes, yes, no, no, maybe, maybe, so. And let's try one more example with substitution. So let's say I have 2x plus 5y is equals to 7, and then 3x plus 6y equals to 11. And I'm trying to solve this by substitution. I gotta pick an equation, pick a variable to get rid of. This time let's get rid of x. And so my first equation is 2x plus 5y is equals to 7. Subtract 5y. And so 2x is equals to 7 minus 5y, and then divide by 2. And so I get that x is equals to 7 halves minus 5 halves y. Uh-oh, fraction alert, fraction alert. So I gotta take this expression and I must substitute it into the second equation. So the second equation was going to change. It's going to be 3, but instead of x, I'm going to go 7 over 2 minus 5 over 2y plus 6y is equals to 11. And I gotta find what y is. Whew. Distribute the 3. 3 times 7 is 21. 3 times 5 is 15. Plus 6y is equals to 11. Now I have a denominator of 2. I can get rid of that denominator by multiplying everything by 2. That's 21 minus 15y plus 12y is equals to 22. And if you look very carefully, you'll notice that all the x's are gone. So now that I have that right here, I will subtract 21 from both sides. And so negative 15y plus 12y equals 1. 15 and 12y gives me negative 3y. And therefore y is equal to negative 1/3. Now that I know that net y is equal to negative 1/3, I can find x. X is equal to 7 over 2 minus 5 over 2 times negative 1/3. X is equal to 7 over 2 plus 5 over 6. And add fractions, and you get a common denominator. So I multiply this by 3 over 3. I can barely squeeze it in there, but that's alright. That's 21 over 2 plus 21 over 6, sorry. Plus 5 over 6. And that is 26 over 6. I can divide by 2. That's 13 over 3. Sheesh. So I get my one solution, which is negative, x comes first, 13 over 3, comma negative 1 over 3. Alright, see you in a little bit.